Our lesson for this evening is to be able to add and subtract rational numbers. This will combine the skills we reviewed at the beginning of the year around adding and subtracting fractions and decimals with the rules we just learned about adding and subtracting integers. Let's start by reviewing some vocabulary and procedures that we have talked about this year. Rational numbers are any number that can be written as a fraction. These include all of our integers in addition to fractions and decimals. We also need to remember our addition rules that we learned over the last couple of weeks. The addition rules state that if the signs are the same, we find the sum of the two numbers, which means we add them, and we keep the sign. So if both numbers are positive, our answer is positive. If both numbers are negative, our answer is negative. If the signs are different, then we find the difference or subtract the numbers. In this case, we would subtract the bigger absolute value minus the smaller, and then take the sign of the larger number. The rule for subtraction is to first change the subtraction problem to an addition problem. We do this by adding the inverse. We keep the first number the same, change subtraction to addition, and use the opposite of the second number. After we've turned it to an addition problem, we follow the rules we just reviewed for addition. Thinking way back to the beginning of the year, we talked about adding and subtracting fractions. One reminder about adding and subtracting fractions is that you must find a common denominator in order to do this. A quick reminder about adding and subtracting decimals is to remember that you must always line up the decimals so that you are adding and subtracting the same place values. Let's try a few examples before you try and work some on your own. So this problem reads 2 1/5 plus negative 1/4. We have an addition problem, so we do not need to change anything. We now need to look and see if our signs are the same or different. This is a positive 2 1/5 and a negative 1/4. Our signs are different, so we need to subtract. A helpful strategy for subtracting fractions is to line them up vertically. So 2 1/5 minus 1/4, I'm going to need to get a common denominator. In order to do that, I am looking for the least common multiple between 5 and 4. Both of these can be turned into the denominator of 20. In order to turn this fraction into a denominator of 20, I'm going to multiply both the numerator and denominator by 4. That means another name for 2 1/5 is 2 4/20. In order to change 1/4 into a fraction with a denominator of 20, I'm going to multiply the numerator and denominator by 5, and I end up with 5/20. To subtract these two numbers, I'm going to need to get some more 20ths because I cannot subtract 4 minus 5. In order to do that, I'm going to borrow from here, rename, take 1 10 away. So instead of 4/20, I have 24/20. I took one whole and made it 20/20 and added the 4 that I already had. Now I can subtract. 24 minus 5 is 19, and my denominator stays 20. 1 minus 0 is 1. So my answer is 1 and 19/20. But I need to check and make sure that my sign is correct. I am looking for the bigger absolute value. 2 and 1/5 is a bigger absolute value than 1/4. And because it is positive, my answer will also be positive. So my final answer is 1 and 19/20. If I look at the second example, I have 2/3 minus -7/9. Now, before I can solve this, I need to follow the subtraction rule, which states to change it to an addition problem by adding the inverse of the first number. So it'll stay 2/3, and instead of subtraction, I'm going to add the opposite of -7/9 is +7/9. Now my signs are the same, so I need to find the sum. Again, I'm going to line these up vertically. So 2/3 plus 7/9. I can easily turn thirds into ninths by multiplying this fraction by 3. So I end up with 6/9, and I don't need to change this, plus 7/9. When we add our numerators, 6 plus 7 is 13/9. Both of these are positive, so my answer is positive, and I can leave it a simplified improper fraction, or I can turn it into a mixed number, which means that this is 1 and 4/9. Let's do 2 more examples that are decimals. In this first one, I have an addition problem. -2 and 75/100 plus 9 and 2/10. My signs are different, so I have to find the difference or subtract. The reminder for decimals was to line up the decimals. So again, I'm going to put these vertically. I'm going to do the bigger absolute value, so 9.2 minus, my decimals goes here, so it's 2 and 75/100. Now I need to fill in any empty spaces with zeros, and then I can start my subtraction. I can't subtract 0 minus 5 from 0, so I'm going to rename one of these tenths here, or borrow. So now I have 10/100 minus 5/100 is 5. I can't do 1 minus 7, so I'm going to borrow a 1 or rename a 1. So now I have 11/10 minus 7/10 is 4/10. My decimal stays lined up so that my place values remain constant, and 8 minus 2 is 6. Now I have to decide if my answer is positive or negative. I have -2.75 and a positive 9.2. So I have more positives than negatives. So my final answer is a positive 6 and 45/100. One final example. In this example, -12 and 7/10 minus -1 and 3/100. It is a subtraction problem, so I need to follow the rules for subtracting, which is to change it into an addition problem by keeping the first number the same, changing it to addition, and changing the sign of the second number. Now, my signs are different. I have to find the difference, subtract. So again, I'm going to put my bigger number on top and my smaller number on the bottom, remembering to line up my decimals, fill in a 0, and when I subtract, 10 minus 3 is 7, 6 minus 0 is 6, the decimal stays in the same spot, 2 minus 1 is 1, 1 minus 0 is 1, so I have 11 and 67/100. When I look back at my numbers, I have more negatives than positives, so my final answer is negative 11 and 67 hundredths. Once you have filled in your capture sheet, try the problems on your own and think about whether you feel like you understand this concept or you need a little more instruction tomorrow during class.